Okay, so basically what you want to do is we're basically going to expand the equation. That's the goal of using the identities. Now you are going to see two different examples. Notice that this is called sum or difference of cubes. And one of the reasons is because one of them is going to be adding, the other one is going to be subtracting. And notice also that they all have to have a cube. They have to be perfect cubes. Just like there's a perfect square, like for example, the square root of 25, it's a perfect square. The cube root of 8 is a perfect cube because 2 times 2 times 2 is equal to 8. So we're going to be working with cube roots. All right. So now I made a typo. So just make sure you fix it. That should be a plus. So question number 1 is asking me to expand 8x to the power of 3 plus 27, which means I'm going to be using sum of cubes. All right. Now, how do we do this? I want to go from this expression to this expression. So watch. The first thing you got to check for is obviously if we have a plus or a minus, we know that it's a plus. The second thing you want to check for is if we have a perfect cube. In this case, a is a perfect cube because 2 times 2 times 2 is equal to 8. And 27 is also a perfect cube because 3 times 3 times 3 is equal to 27. So we can actually apply the identity. Now, how are we going to apply it? We're simply going to take the cube root of each one. Okay. And that's going to give us the x, and that is going to give us the y. Okay. Basically, this is going to give us the x, and this is going to give us the y in the equation. All right. Well, what is the cube root of 8? We know that the cube root of 8 is 2. So that means x is equal to 2. And what is the cube root of x to the power of 3? Well, the cube root of x to the power of 3 is x. Now let's simplify the second one. I need to know what y equals. Well, what is the cube root? And sorry, I forgot the cubed. What is the cube root of 27? Well, the cube root of 27, as we know, is 3. Okay, so basically what I did is I simplify this to that, and I simplify that to that. So now that I know my x and now that I know my y, I can just plug them into this formula. Okay, and I'm just going to write the formula just so you can see it and just so you know what I'm doing. All right, so I'm going to go ahead and plug in my x and my y. So my x is 2x now, and my y is 3. So for every x, I'm going to put 2x. For every y, I'm going to put 3. And then I got x squared, which is 2x squared minus x times y, which is going to be 2x times y, which is a 3, plus y squared, which is, what is my y? My y is 3. So notice that I first put them into parentheses just to make sure that we are actually simplifying this correctly. All right. So we got 2x plus 3, nothing to simplify there. And now the first one, we got 2x to the power of 2. Well, that would be 4x squared. And now we got 2x times 3, which is 6, but there's a negative in front of it. So that's going to be negative 6x. And finally, we got 3 squared, which is just 9. So notice that we were able to expand this expression into that expression by using the identities. And this would be my answer. Okay. Again, this is basically factoring. Now for number 2, notice that we do have a minus, but we don't have a square, and that is going to be a problem. Okay, now obviously there's not a 3, so I cannot use difference of cubes. But let's see if we can simplify this, and maybe after I simplify, I can use one of the identities. So I noticed that there's actually a common factor. My common factor is 2x. So I can actually take a 2x out of the two expressions, or out of the two terms. So if I divide that by 2x, and remember, when you do that, you're still going to have the 2x, it's just going to be outside. So we're left with 2x squared, 2x to the power of 4 divided by 2x, which is just x to the power of 3. Minus 16 divided by 2, which is a, and then x divided by x is just 1, so that's gone. And this is what I'm left with. Okay. All right, well, now look at the inside expression. We do have a minus and we do have a cubed, which means we can use this identity. So let's go ahead and expand it. And let's do the same thing. So I'm going to take the cube root of this, and I'm going to take the cube root of that to find my x and to find my y. Cool. Well, the cube root of x to the power of 3, we know that's just x. And the cube root of 8, we know that's just 2. And now let's just go ahead and use the formula, which is this one right there. So that's x minus y, x squared plus xy plus y squared. And I'm just going to go ahead and plug it in. Well, x is x, y is 2, so that's going to be x minus 2. And then I got x squared, which is just x, plus x times x, or x times y, which is x times the 2, plus y squared, which we know y is just 2. So again, I'm just literally plugging them in. I don't like to simplify them on the same step because it's just kind of confusing. But anyways, now that you plug everything into the formula or the identity, let's just call it identity, we can just simplify it. So that would be x minus 2. We know that x squared is just x squared, right? And then we got x times 2, which is just 2x. And then we got 2 squared, which is just 4. And that would be my answer. So again, we're going to be using identities to expand a polynomial expression, specifically the sum or difference of cubes. Remember, it has to have a plus or a minus, and they have to be cubic functions or cubic expressions for you to be able to do this. Okay, so what I want you to do is go ahead and do the next 2 problems. Check your answers with your partners. Or whoever the person next to you is, or get into groups. But other than that, once you finish those 2 problems, the sub should have given you a practice sheet. So just go ahead and do that practice sheet, and that's all you got to do for today. All right. See you guys.